Here's how you actually maintain a continuous conversation with an AI while keeping all context perfectly intact between messages. We'll see exactly how to initialize a thread, stream updates in real time, and watch the AI's state persist seamlessly, all with just a few lines of configuration. The pattern handles the full lifecycle, starting fresh, processing each message, and preserving the complete history for the next interaction.
Invoke the graph. Userid 1. Config configurable. Threaded 1 userid user. Firstlet just say hi to the AI. For update in graph stream. Messages role user content. Hi config stream mode equals updates. Print update.
This demonstrates the thread persistence pattern in stateful workflow systems. The concept revolves around maintaining conversation continuity by persisting execution state across interactions, where each thread represents an isolated state container tied to a unique identifier. What makes this distinctive is the ability to pause, inspect, and resume complex workflows at any point while preserving complete execution context. The pattern works by checkpointing state at each logical step, creating a linear history of execution snapshots. These checkpoints capture not just data values, but also the control flow position, allowing the system to reconstruct the exact state at any previous point. This temporal architecture enables features like time travel debugging, where you can replay execution from any checkpoint, or human-in-the-loop interventions, where operators can inspect and modify state mid-execution. This approach solves the problem of stateful coordination in long-running, multi-step processes. It's particularly valuable for conversational AI systems, approval workflows, or any scenario requiring auditability and recoverability. The trade-off is increased storage requirements for maintaining state history, but the benefit is complete execution transparency and the ability to handle interruptions or failures gracefully without losing context. Let's break it down line by line.
Invoke the graph. Userid 1.
Sets a hard-coded userid for testing. This simulates an authenticated user session before invoking the graph, ensuring we can track interactions by user.
Config configurable. Threaded 1 userid user.
This code sets up a thread-specific configuration for LangGraph by passing a config dict with threaded. 1, to isolate the conversation state, and userid for tracking. The structure matches LangGraph's runtime config format, where configurable holds thread-scoped parameters, ensuring all updates in graph stream are bound to this thread while preserving user context across interactions.
Firstlet just say hi to the AI. For update in graph stream.
This initiates a streaming interaction with the graph. The for loop processes each update as it arrives, enabling real-time handling of the AI's response stream rather than waiting for a complete response. This pattern is essential for interactive applications where partial results need immediate processing.
Messages, role, user content. Hi config stream mode equals updates.
This streams a user message, role, user content, hi through the graph with stream mode equals updates, which emits intermediate state changes like tool calls or partial agent reasoning as they occur, unlike stream mode equals values that only yields final outputs. The config ties the interaction to a specific thread, thread ID equals 1, and user context.
Print update.
This prints raw streaming updates from the graph, where each update is a dictionary mapping node names to their incremental outputs, e.g., partial messages or tool calls. The official docs show how to process these per node updates, like extracting node update messages and pretty printing. But this snippet just dumps the raw structure for debugging. LangGraph configuration pattern. The configurable object with userid and threaded establishes persistent conversation contexts, enabling stateful interactions across multiple graph invocations. Thread IDs must remain unique per conversation, while userid ties all threads to a specific user session. This simple pattern unlocks complex multi-threaded workflows without changing your core graph logic.
The config that binds two threads holds no conversation.